Hello, check. I'm audible. A very good evening, guys. Let's get started. All right. There was a bit of glitch in here, so sorry for being late. And let's see if we can start it. All right. So we are going to talk about casting process 1 today. Okay. Again, we are going to go into it and we are going to take some concepts through some questions. All right, guys. My name is Rahul KANYAL and you are watching Gradeup. All right, and if you have not subscribed to our channel, please go ahead and hit that subscribe button for us. Okay, and keep on sharing these videos, these free videos, so that others can also be benefited, guys. All right, so let's get started. So how are you guys doing? Just type in how are you guys doing. All right, I have to set up my phone as well. Yes, so yeah, now this is my profile. I am a senior faculty for mechanical, GATE and ESE. Okay, all right, now there's another series that I take daily. All right, guys, and that's called Concept on Fingertips, and I take production Mondays to Friday every day at 2 p.m. Please don't forget to tune into it. All right, I'm good. Gopi, Shivendra, very good evening. Satish, Sri Kumar. So that's what it is. Yes, Sri Kumar, this is the first class of manufacturing here. Is it good? Sanjeev, so how are you doing? Yep, so we have a target GATE 2021 class of batch 2 that is getting started, and you can start always a free trial with us, guys. All right, and again I'm going to repeat that if you have not hit the subscribe button or like button, please go ahead and hit that, okay, so that we get motivated enough to bring you such videos, guys. All right, now yes, we have 500 plus hours of live classes here with us. All right, and you can tune into us if you believe that we can take you there. All right, now what is the casting process? So how many of you know casting process? If you know casting process, just type in I. If you don't know casting process, just type in I. Now, so let me tell you that casting is the most, what we can say is it's the oldest manufacturing process, right? Is the oldest manufacturing process. All right, is it good? Yeah, Satish, so it's really good if it's your it's your first class. So yes, so what happens here? Okay, fine. So how many of you don't know exactly what a casting process, or even don't bother about that, because we are here to help you. Okay, now it's the oldest manufacturing process. What happens is this molten metal, okay, the metal, okay, this is METAL, okay, yeah, so this molten metal is poured, all right, this poured into a cavity. This is a cavity. I hope you understand a cavity, right? It's a what do you call a cavity? Cavity is a hollow passage, you can think something like that. Okay, now it's molten metal that is getting poured into sprue. Now through sprue, okay, this one is sprue, all right, this one's given, it's called sprue. Okay, now it flows into cavity. Now this is called runner here. This portion over here is called runner, right? Now Rohit, yes, so so if you ask me the rank about IISc, yes, so now it depends on the branch that you are going to hit. If you're talking about mechanical, then yes, you might get it if you get AIR 50, all right, AIR 50 within this rank, certainly you're going to get a direct call from there, okay, a direct admission. Okay, now this is a cavity here, all right. Now the molten metal fills into cavity like this. Are you getting this? Hello, a very good evening to you guys. All right, so what is happening here is the molten metal is filling in this cavity like this, okay, like this, now like this, now like this. Okay, now what happens with time? This solidifies. Okay, so with time the molten metal solidifies, isn't it? it just solidifies. Okay, when molten metal solidifies, what happens is we get a product, right? That's what it is, isn't it? Is that good? Yeah, Rohit, so we'll talk about that. Okay, we are not here to exactly talk about that, but yes, please hold on to the end of session. If you remind me for your queries, for your question, Rohit, I'm talking to you, all right? Then I'm going to certainly reply to you. Okay. Okay, engineering mathematics. Dharmesh, yes, I think our team can even think about that. Okay, engineering mathematics. Yes, certainly. Is it good? Is this clear to you? So I'm going to just repeat it for you. So what happens here is molten metal is poured. Okay, it flows through runner. It goes into a cavity. Then it solidifies. It's very easy. Is it good? Hello. If you could understand it, just type in I. Okay. Just type in I. If you could understand it. If you could not understand it, just type in I. Is that good? So that's all about the casting process. Okay. And now we are going to take some questions here. Okay. Now the questions, these are the competitive based questions and they are very, very, very important to you. Okay. Let's take this. Now a riser is designed so as to. Okay, now let's talk about riser here. Okay, so what is riser? Now riser is this hole over here, right? This one is riser. So the function of riser is, what is the function of riser? A riser provides for the extra material to the casting. Is it good? Yeah, Srinu, I'm really good, Srinu. Thank you for asking, right? So riser provides for the extra material to the casting. That is what riser does. Okay, now this is riser. Are you getting this? So here the molten metal flows something like this into the cavity, then to the riser. Okay, yes, Sargam, you're right, exactly. So it provides for the extra material to the casting. Now there's one condition of riser. What is that? There's just one condition of the riser, that it should solidify at the last. It should solidify at the last. Okay, it should be the one to solidify at the last. Then we call this as, we call something like this. This is also called directional solidification. Okay, directional solidification. It means that the solidification must be towards riser, right? Must be towards riser. That is what is the meaning of directional solidification. Okay, so let me tell you. So which one should solidify first here? So what it says is this sprue should be the one to solidify first. Yeah, Sri Kumar, you're right. Good. You're doing good. So how are you guys? How is the Josh? Just tell me. Is it high? Now this sprue is going to solidify first. So I'm going to just write 1 here. Okay. Then this runner is going to solidify second. Okay. Then this in-gate is going to solidify third. Alright. Then this cavity, this mold, the casting that we are talking, is going to solidify fourth. Then the riser is going to solidify at fifth. That's what we are talking about here. Alright. So what should I write? Sequence of solidification. Okay. So sequence of solidification should happen what? First one is sprue, second one, it can be something like this. Okay, so I'm not saying all the times it will be like this, but yes, most of the cases it can be like this. All right, so sprue, then runner will solidify, then gates are going to solidify, then the casting is going to be solidified. All right, then the fifth one should be riser. That's what it means. Okay, so this is the sequence. Are you getting? Now please tell me, now which option do you think is correct here, A, B, C or D? Let's do this, come on. Yeah, Srinu, so what do you think about this? So riser is designed so as to what? Satish. Now this is a question from GATE, let me tell you this, okay? So if you can solve these questions, GATE really becomes easy for you guys. So what do you think? Come on, chalo, let's do this. So GATE, this is from a GATE question, okay? This is actually a GATE question. So what do you think? A, Sanjeev Kumar says A, Srinu says A. So A, option A, Sanjeev, Satish, yes, Vijay also says A, Sargam also says A, Gaur Parth also says A. All right, good. What about others? There are 38 people watching this, right? So A, it should be A, right? So freeze after the casting freezes, obviously, okay? Is it good? So good, well done guys. So it should be A. Now hit that like button if you're liking this, okay? Because it will help me to make more videos, us to make more videos. All right guys, chalo, let's do this. Roshan, yes, you're right. So good, well done. One of you is correct in this. Okay? Yes. So the contraction allowance provided on the pattern and core boxes compensates for the following type of contraction. Let's talk about contraction first, okay? So obviously, you know, there's a casting, okay? It solidifies and it contracts. Okay, or let me just write it something like this, okay? So casting, what it does is it solidifies and it contracts, all right? Yes? Is it good? It solidifies and it contracts. Now it happens in 3 stages, guys, all right? So there are 3 stages of contraction. Number 1 is what? So that is nothing but, you know, molten temperature, molten or pouring temperature, I should call it, okay? So what is pouring temperature? Just type in if you understand it. Pouring temperature means the temperature at which we are pouring here, right? This temperature, molten metal. So this temperature here. So the temperature at this point is called pouring temperature, right? So what we call it as pouring temperature. Are you getting that? Yes. Okay. So most people know this. Okay. So pouring temperature to freezing temperature, right? So we have one contraction like this, okay, then a phase change from liquid to solid, right? And the third one is freezing temperature to room temperature, okay? So freezing temperature to room temperature, that's what is happening. So we call this third one as solid contraction, okay? Okay, and because an object or, you know, any 3D object, for example this thing, okay, let's say that this thing, all right, and let's assume that it is metallic, okay, when it's contracting, obviously it's losing the size, right? So the pattern that we use, we make it a bigger, right? Isn't it? Oh, Ramesh. Okay, Ramesh, I'm really glad to hear that. Thank you very much. You also great. Okay, you guys also great. Really great, looking good out there. Okay, so it is called solid contraction. Now, when we are talking about the contraction here, okay, we are just talking about contraction allowance or shrinkage allowance. So shrinkage allowance is nothing but, should we make the pattern a bit bigger or a bit smaller? Can you please tell me? So I'm saying that, okay, I hope you know this word, right? Pattern. So whatever you make, okay, let me tell you what pattern is, okay? Now let's say that this is a cavity, all right? Now this cavity is made with the help of a pattern, okay? So this cavity is made with the help of a pattern. So what happens is, this shrinkage allowance, there's something called a shrinkage allowance, all right? So it always takes care of this third phase over here, okay? The shrinkage allowance, this is what you need to remember. The contraction allowance or the shrinkage allowance always takes care of solid contraction, that we are saying freezing temperature to room temperature, right? So yes, Sri Kumar, you're right. It has to be made a bit bigger, right? Because ultimately there's a shrinkage here, right? Isn't it? It's going to be shrunk a bit, isn't it? Because of solidification. That's what we are saying. So pattern has to be made a bit bigger. So that's this bigger, okay? Now how much bigger? We are calling it as, shrinkage allowance, okay? This we say at shrinkage allowance. Is it good to you guys? Is it good? Is it good? Yes, Sri Kumar, you are saying, you can say that. Yes, exactly. So size plus tolerance, you can say that. Is it good? Hello. Now, so solid contraction is always, is taken care of by the allowance. Is that good? Now, please tell me, chills are used in molds. All right, now we have talked about, right? We have talked about, okay, let's talk about chills, okay? Are you chilling out there is the question, right? Okay, so what we said is, we said that, okay, riser, this should contract, or this should solidify at the last, right? So riser should solidify at the last. That's what we said, right? Isn't it? Now to achieve this, sometimes we have to use chills. All right, you're not chilling, Madhurya Bhuyan. What happens? So use chills to achieve directional solidification. So directional solidification, that's what you need to know. All right, so chills are yeah Sargam, that you can also say, all right, to increase the heat transfer, okay? Generally chills have high thermal conductivity, okay? They have high thermal conductivity, okay? So chills, let's say that, I found that, okay, this is okay, let's say that I found that it's getting solidified from here, right? Let's say that this is the point in which it's getting solidified, but we don't want this, right? If it gets solidified, then the passage of molten metal is lost, okay? So what I did, I just put in, okay, I say that, okay, just put a chill here, okay? Let's say that I just put a chill here at this point, so that this portion over here gets solidified. So in other words, so what is the option here, okay? So according to the discussion, please tell me if it's A, B, C or D. So chills are used in molds too. Yeah, Arpan Patel says it's A. Ramu also says it's A. Yes. What about others? Arpan also says yes. Sri Kumar, you have said it. Good, very elegantly. Good, well done. So what do you think? Which option? I have told you everything, right, guys? So what do you think? Yes, good. Sanjeev, Kumar, Gyanasekharan, try to teach GATE full syllabus. I am trying, Gyanasekharan, okay? Constant temperature. Sure, Sanjeev, Shrinu, Gaur, Parth. Yes, it is A, okay? Achieve directional solidification, alright? Is it good? Now, please remember that it can be internal as well as external chills, okay? So, please remember that. Okay? Is that good? Yes. Okay, fine. So, the next question. So, increase in water content in molding sand causes. Okay, now let's say that. Okay, let's say that there's a sand, okay? Let's say that this is sand, alright? Let's say that this is sand. What happens if you increase water in this? So, if you increase water in this, right? Let's say that increase water. So, that's what is the question, alright? Let's say that the water molecules are like this, big. These are the big water molecules, something like that. Okay? Is it good? So what happens? Flowability to go through a maxima, permeability. Now let's talk about these, okay? So first of all, let's talk about what is flowability. Okay? Now what is flowability? Flowability means that, okay, so let me just get rid of these. So can anyone explain what is the understanding of flowability means? Ease of flow, right? So flowability means ease of flow. Permeability means what? Ease of escape of gases. Gases are not good, let me tell you. Are they good? They are never good, right? Now compressive strength, you know, right? Is it good? So what happens here is, so flowability, if I just talk about flowability, if I just make a diagram, flowability of molding sand over here, and I say that, okay, this is water here. So it goes something like this, okay? It goes something like this. Are you getting this? Is it good? So this is flowability. Now let me make permeability. So if you talk about permeability, so it goes something like this, alright? So permeability goes something like this. And this is water. Is it good? Okay, now is it good, guys? Is it coming? I don't know why this is not coming. Even my internet is working here. Is my video not working? Oh. Is it coming? Hello? I don't know if it's coming or not. Just tell me, guys, is it coming or not? Now it's working, right? So please tell me which one of the options is correct, right? It somehow happens, right? Sometimes it goes down, comes up. Okay, fine, guys. So which option is the correct option? So I have made 3 graphs here, right? Now this is strength, this is permeability, this is flowability. Now what? So which option do you think is correct? Come on. Let's do this. Coming, right? So is it A, B, C or D? B for Bombay. Babu Rao says it's Bombay. Yes, obviously it's going to be permeability because it goes through a maxima here, right? This is what is the meaning of that. So this point here, this is called maxima, right? This is the maximum value. This goes through a maxima. Now this one is also a maxima over here, right? This also goes through a maxima. Yes, so B is the option, guys. All right. Is that good? So how many of you got it correctly? Okay. Okay, fine. So Vishal, what I mean is that, okay, just hold on. Okay. This is a minima point here, right? This one. This is a minima point, right? And this is a maxima point. The maximum value of permeability is the maximum point, right? Is it good? This is the minimum point. This is the maxima point. This is also a maxima point. So which one of these is correct? Correct. So flowability to go through a maxima. No, it's not going through a maxima. It's going through a minima. So this is wrong. Permeability to go through a maxima. Yes, it's going through a maxima here because this point is maxima, right? So this is correct. Compressive strength to go through a minima. No, it's going through a maxima here. That is what I mean. All right. I hope this is good. Akhil, how are you doing? I hope you're doing good. Enjoying the session? Okay, my friend Akhil Gupta. Fine, thank you. Just, share this video, Akhil Gupta. Alright, now Janki Ram. Again, we'll have to go through lots and lots of things. Alright, now if you want to understand it, just hold on till the end. Okay, we'll understand it. Alright, it is going to take around 20 to 25 minutes, but I'm willing to go ahead if you want. Alright, okay, now let's do this. So two cubical castings of the same metal and sizes of 2 centimeter size and 4 centimeter size are molded in green sand. If the smaller casting solidifies in 2 minutes, now let me tell you, okay, so time required to solidify is what? Time required to solidify is given something like this, right? So K V upon A whole square, right? Where V equals to volume, right? And A equals to surface area. Isn't it? Yes. Isn't it? So V equals to volume and A equals to surface area, right? Isn't it? Yep. Now this is T equals to KV upon A whole square. Now what is given to us? So what is given to us? So V equals to volume. Okay. Now let's say that let A equals to edge of cube, right? Of cube. So V upon A, volume per unit area, is A cube upon 6A square, right? So what is that? So A upon, this is what? 6, right? Let edge of cube is nothing but, A upon 6. Are you getting that? So time is what? A upon 6 whole square, right? So time taken to solidify is Ka upon 6 whole square. Now what is time taken to, so if the smaller casting solidifies in 2 minutes, okay, so what I'm going to say is T1 equals to or what I can write is, so T1 upon T2 equals to A1 upon A2 whole square, right? Can I write something like this? So T1 upon T2 equals to A1 upon A2 whole square, because this is always the same. K is always the same here, right? So what is T1? So if the smaller casting solidifies in 2 minutes, so T1 is given to be 2 minutes, and we just have to find Okay, so A1 is how much? That's 2. Okay, and what is A2? That's 4. It's given to us, right? So what is T2 here? So T2 equals to how much? So that's 8 minutes. Right, C for Chennai, Babu Rao. Sorry for that. Are you getting this? So we were given what we were given is A1. So the length of smaller casting here, right? That is 2 centimeter, right? So A1, so given A1 equals to 2 centimeters, right? A2 equals to 4 centimeters. It's given, right? 2 centimeter and 4 centimeter. Now smaller casting solidifies. So T1, smaller casting means this 2 centimeter one. It solidifies in 2 minutes. So we had to find T2. Are you guys getting this? How much of you got it? So T2 is nothing but 8 minutes. We just used this formula, guys. Okay. This formula was being used here. Is it good? Hello, how many of you got it? So it's C, 8 minutes. K is nothing but a constant, right? A solidification constant. Okay, Babu Rao, no, I fear no, you cannot appear. Okay? Okay, so C is correct here. Alright guys, hello. I hope that you guys are enjoying this class and you're going to go back and do a quick revision, alright? Because revision is really important, okay? Now, please tell me this. The pressure at the in gate will be maximum with gating system. Now, what is this? Now, there's something called a gating ratio, okay? Here, gating ratio is nothing but sprue area ratio. Sri Kumar, are you getting that? Is it good? So sprue area is like this, all right? Okay, fine, good. So sprue ratio area, sorry, to runner area, is that good? To gate area, that's called a gating ratio. All right. So here, what is the meaning of this? So 4:8:3 means the ratio of sprue area comma runner area comma gate area equals to 4:8:3. That is what is the meaning of that. Okay, now now please tell me what should be the answer of this. So pressure at the in gate will be maximum. So what is in gate? Let's go back to this okay. So no, I just pressed something really bad here, right? I don't know how do we get back. Yep, we are back. All right, so this sprue, okay, this cross-sectional area of sprue, this one, the runner, this one, and the in-gate, that's what we are saying, that's what is given to us. Now, you just need to tell, okay, which one of them is going to have more pressure. Is there any difference or any relationship between pressure and area? So pressure is directly proportional to area, right? Or I'm going to just write it's directly proportional to change in area. So change in area, right? So wherever the change in area is maximum, isn't it? So pressure has to be maximum, right? So can you please tell me? So change in area maximum, or or I should say increase in area. So whatever is your understanding through this, right? So what do you think? So pressure is directly proportional to change in here. Okay, now the pressure at the in gate will be maximum with the gating system. Now this one is sprue area, this one is runner area, this one is gate area, right? So the area from risers or runner to gate should increase, right? Hello. So the area, what I'm saying is, from runner to gate must increase, so that pressure increases, right? Hello. So that pressure increases. So which one of these options is telling you the maximum increase from runner to gate? Please tell me now. Now which of the option is given to you that the area is increasing the maximum, right? That's the concept here, isn't it? So pressure is directly proportional to change in area, isn't it? Yes. So which one? Exactly, Sri Kumar, right? So which one is, there's an increase in area here, right? Because the velocity is decreasing, so the pressure must also increase, right? According to Bernoulli's as well. So it has to be C. Okay, but just remember this thing. So pressure is directly proportional to change in area. So therefore, C must be the correct option, guys. Come on, guys, just comment it. Okay, just comment it. Okay, because I know that you have understood it. So pressure is directly proportional to change in area. So C must be correct, all right, according to this concept. Now the next question. Is that good? Now converging passage is used for feeding the liquid metal into mold. 2. Got it, Srinu? Yes, good. Samyak, yes. Are you getting this? So here, see, okay, let's go back, okay, because people are not talking here, right? So from runner to gate, is it increasing? No, it's not increasing, it's decreasing. So I'm going to say -5. Cross sectional area is -5. This is change in area, guys, okay? So that is 3 minus 8 is -5. 3 minus 3 over here is 0. 4 minus 2 is 2. 1 minus 2 is -2. So in the C option, there's a maximum change in area, right? So that's why I'm saying that it has to be C here. Alright? Okay? Okay, now converging passage is used to feed the liquid metal into molds. Now what is the meaning of converging passage? Let me tell you, right? Now this one, see. Now this one is a converging passage here, okay? This is not cylindrical, it's kind of this, okay? It's kind of this. So this is cylindrical and this is kind of converging like this. So this is correct and this is not correct. I am talking about this sprue here. I am talking about this region here, sprue region. Okay, we are talking about sprue here. Is that good? Okay, so this is what is the meaning of converging or converging cross section or whatever, converging passage, right? So this is done to actually avoid aspiration of air, right? Now what is aspiration of air? That's nothing but if in the passage of molten metal, let me explain it, okay? if in the passage of molten metal the pressure becomes lesser than atmospheric pressure, okay, lesser than atmospheric pressure, okay, so gases, what do I say, diffuse inside the molten metal, leading to casting defect called porosity. All right, so casting defect called porosity. So this is called porosity, right? Yeah, SITI. Okay, so D is the option here. It is the passage of molten metal. If in the passage of molten metal the pressure becomes lesser than atmospheric pressure, so gases diffuse inside the molten metal, okay, molten metal, leading to casting defect called porosity. That's called aspiration. And believe me, we don't want this, right? Because we don't want any defect, right? We want healthy castings. Is it good? Could you understand this? Just type if you could understand it. Type in I if you could understand this, guys. Just 4. Okay, so Narendra was right, Naveen was right, Arya, Shubham, Sanjeev was right. Okay, Arpan Patel was also right. Okay, is it good? Just type in I, guys, if you could understand that. Okay, Srinu, so what is happening here at, okay, fine, so Srinu, so let's say that Srinu here, let's say that at this point, let's say that the pressure drops beyond atmospheric pressure, all right, at this point here. Okay, so what is going to happen, that the gases that come out, okay, the gases are also going to come, right? Gases are everywhere, they are there. If the organic material burns, then gases are formed, right? So they're going to just diffuse in this point, right? They are not going to go anywhere. They are going to go to this point where the pressure has dropped, or let's say that here the pressure has also dropped. So gases are just going to come to this point and move inside the molten metal, okay, and we don't want that. So that is what is the meaning of aspiration here. Is it good? So just remember that okay, the converging passage, okay, is done because of aspiration. Yeah, Sri Kumar, I can do that, right? So Sri Kumar, I'm going to say that Ghosh and Malik is a very good book, okay. So Ghosh and Malik is a very, very, very good book, all right. Ghosh and Malik is a very good book, and what I would say is, and what do we say, Ghosh and Malik, and this one more, Kalpak GN, right? Kalpak GN is also a good book. So you can refer these two books, brilliant books, right? Sri Kumar, I hope that I answered you, alright? So this is what is aspiration, okay? Are you getting this? So I'm going to again repeat it. Aspiration means that, let's say that this point the pressure drops below atmospheric pressure, okay? Now there are gases everywhere, okay? There are so many gases. So these gases will try to diffuse to this point, okay? They will just get trapped at this point. So that is what is the meaning of aspiration, all right? Is that good? Pawan Kumar, believe me, I'm just trying my best, okay? It's difficult writing in these tablets here, okay? Okay. Okay. Now, yes, I think, guys, okay, let's take a last question. In a green sand molding process, uniform ramming leads to, okay, let's say that Okay, firstly, let's understand this question, all right, guys? So, in a green sand molding process, uniform ramming leads to. So, what is the meaning of a molding process here? So, molding process means that, see, this is a box. Okay, this is a box. This is an empty box over here. What we do is we just put sand into this box. All right, and this process is called ramming. इसको हम ramming बोलते हैं. All right, this is nothing but ramming. Is it good? Now the question is that, okay, because, and why do we do this? We do this to form a cavity here. ठीक है? So this is a box, this is a sand. We just pack this sand inside the box. Okay, so what it says is, uniform ramming. Uniform ramming means packing, okay? Uniform packing. Are you getting that? Leads to, if you uniformly pack it, okay, everywhere there's an equal density, right? So what happens? So that's what it's asking for, right? So uniform ramming means uniform density. So it's asking for uniform density, right? So what should it give you? Less chance of gas porosity? No. Uniform ramming will not give you less chance of gas porosity. Now, porosity depends on the grain size. Now, let's forget about that, right? So, what do you think it is? Uniform flow of molten into the mold cavity. This is also not related, right? How is density related to uniform flow of molten? Less chance. This is also not correct. So, what about this? Greater dimensional stability of the casting. It is true, actually, okay? It is a possibility. Greater dimensional stability of the casting, all right? What it means is, dimensional stability means that it's not going to deform. It's not going to deform. That's what is the meaning of dimensional stability, right? So yes, if you do a uniform density packing, obviously the stability is going to be more, right? Isn't it? So the answer here is C. Greater dimensional stability of the casting. Let's go back to this figure here, right? So if there's the density here is same, okay, all the places the density is same. So it will have more dimensional stability, right? Kyo? Hello, is that good? Yes, Sanjeev, yes, you're right. So it should be C here, okay? Greater dimensional, sorry for that, stability of the casting. Is it good? Hello? Are we good, guys? Are we good? Yep, Freenu, good to see that. A very quick comment. If you're good, so just type in I. Okay. And that's why, the answer is C here, right? I have explained it to you why it's a C. Isn't it? Yes? Right. Now, okay, now we are done here, guys. Okay, we have next class. We'll take casting process 2. At the same time, we are going to meet, and this speaks of the achievement that we have made this year. And thank you very much. My name is Rahul KANYAL, and I'm going to see you again tomorrow. I hope that you liked the session. Now, if you like the session, just subscribe to our channel. If you have not subscribed, keep on sharing this video with others, because they should also be benefited. Take good care of yourself, right? And then come back. Please come back tomorrow, okay? Yep. Is it good? Is it good? Thanks, Arpan Patel. Thank you very much. Now, is there a person who is asking about this, right? So, how is this flowability something like this, right? Is someone asking this, right? Who was the guy? Now we are done. If you want, you can leave, okay? Chalo. We'll talk about skim bog, right? So, Sanasi, thank you very much. So, is there a guy? There was a guy, right? So, Ranvin, same time, okay? 9 p.m. we are going to see you again. And also at 2 p.m. I also take concept on fingertips. Tomorrow as well, we'll do that, okay? So, yes, is there the guy? Is there anyone who was asking about this? Why is this happening? Something like this. So I think the guy has left, so don't bother. All right, and okay. Yeah, Hari Prasad, I'm really good. Okay, so thank you very much, and press the bell icon and get notified for the latest videos that we guys post for you guys. Thank you for asking. Okay, Hari Krishna Prasad, thank you very much, and God bless you. Please go back, revise, come back, smile. Why smile? Because smile leads to success. Okay. Success never leads to smile, okay? Now, this is my own experience. Thank you very much. Okay? Thank you, guys. All right? Now I'm done. Is it good? Now, Hari Krishna, do you have a question? Okay, so I'm going to see you again tomorrow. Thank you, guys. All right? Take care.